So question 8, again, I really could just be doing this on the calculator, couldn't I? So I've just tapped it in as a fraction there. It's given me the answer, and then I've changed it to its r theta format. So we're expecting this to be 1, so just e to the 2/3 pi I is the answer we're aiming for. Should we do it in longhand? Hey, well, look, this here, we can find out the length of that. So the modulus of that is 2. And so the argument of this, the inverse tan of those bits there, is going to be pi over 3. And on the bottom, again, it's 2. And this time it's a minus pi over 3 there. The 2's cancel out, and we take away the powers. So we get e to the 2/3 pi I, just like the calculator got there as well. And so part B says we want to try and do this to the power of n and make it a real number. So if I'm doing e to the 2/3 pi I to the power of n, for that to be a real number, so what we're going to get here, of course, is e to the 2n pi over 3 I. And for that to be a real number, this angle here, so looking at 2n pi over 3, is going to need to be a multiple of a real number. So it's just going to need to be 0 or 2 pi or 4 pi or 6 pi or anything like that, going round and round and round. So I think the n is positive. Positive integer. So n is 0, we can't have because it's not positive. So how about just n is 3? If I've got n is 3, we'd have that one there. But n is actually going to be any multiple of 3, isn't it? Any multiple of 3 going up would give you a real part each time.